This short video is going to explain how we can use the dot and cross diagram to show the formation of the ionic compounds. Here I am going to use the example of the formation of sodium chloride. As you can see in the screen that sodium ion, I am going to explain how sodium ion is formed. Sodium ion is formed from sodium atom. The atomic number of sodium is 11, means it is having 11 proton and 11 electrons. The arrangement of these electrons is, as you can see on the screen, in the first shell we are having 2 electrons. In the second shell, as per the rule, we are having 8 electrons. So the remaining 1 electron will occupy the third shell, which is going to be the valence shell for sodium atom. So here 2, 8 and 1 is the electronic configuration for sodium atom. In order for it to form the sodium ion, sodium will lose the 1 valence shell electron. As you can see here, how sodium ion is formed. The valence electron, which is 1 in this case, is lost by sodium atom and forms the sodium ions. So how do we show the dot diagram for the sodium ion is, in the first shell 2, in the second shell 8 electron, as the third shell will be removed and disappear as sodium has lost 1 electron. So in the square bracket we are going to show it, and they will put a positive sign over it, and this positive sign completely depends how many positive signs would be. That depends on how many electrons the atom has lost. In this case, as sodium has lost just 1 electron, so we are going to put just 1 positive. You can write positive 1, you can write 1 positive, you can write just positive if it is 1. So this is how we show the sodium ion formation, or we can draw the sodium ion. Moving to the next, you can see that here it is showing the formation of the calcium ion. The atomic number of calcium is 20. In the first shell 2 electrons, second 8, third 8 and fourth shell 2 electrons. These 2 electrons can be easily lost by the calcium ion if any atom approaches it, if that atom requires an electron. So calcium can easily donate its 2 electrons, so the electrons will be lost, as you can see on the arrow. Written that calcium is attaining its octet by losing 2 electrons from the valence shell. As these electrons are from the valence shell, so these are called as a valence electron, and this is how we can show we can draw the calcium ion. First 2, then 8, then 8, and then the last shell is disappeared because calcium has lost the 2 electron. And see, it is written positive 2 or 2 positive here, and the electronic configuration will reduce to 288. So this is how we can show the formation of the positive ion cations. The first example we discussed was sodium ion, and the second was calcium ion. Now let's move further and see how we can show or draw the anion formation. As we know that non-metals form the negative ions, they are called as anions. How can we show or draw the negative ion? We are going to take the example of chloride ion. Chlorine atom is having atomic number 17. So electronic configuration will be 2, 8 and 7. First 2, then second shell 8 and the third shell 7. To attain the octet stability or to complete its octet, it is going to gain 1 electron. So after gaining electron, we are going to show put the chloride ion, which is formed by gaining 1 electron. So we are going to put it into a square bracket and we'll put the negative charge. It is very similar to the cation charge, like in a sense that if it is cation, it is positive, if it is an ion, it is negative. And as in the cation, I have told that if the atom has lost 1 electron, so it will be positive 1. So if the atom has gained 1 electron, it will be negative 1. So it's completely fine if you just want to write negative or negative 1 or 1 negative. So if it is 1, you just put as negative sign, that's perfectly alright. And another example is the formation of the oxide ion. This is how oxygen is having 6 electrons in the valence shell. Total it is having 8. So in the first shell 2 and then 6. So it needs 2 more electrons to gain its stability or to complete its octet. So the oxygen atom is having the electronic configuration of 2, 6 and ion is having the electronic configuration of 2, 8. As you can see on the screen, it has gained 2 electrons, so the charge would be -2 respectively. Now the most important question which you observe in the CIS paper is show the formation of different ionic compounds. They can give either sodium chloride or magnesium chloride or magnesium oxide or calcium chloride. Whatsoever ionic compound is, the same rule is going to be followed. So we are just going to understand what steps we are going to follow. So the first step would be you are going to write the electronic configuration and draw the electronic configurations at the same time for the neutral atoms. As sodium is 11, so 281, and this is how you are going to draw it. Chlorine is 17. We are going to write the electronic configuration 287, and we are going to draw this like 2, 8 and 7. As you can see, the cations are shown by the dot and anions are shown, non-metals are shown with the cross. So that's why it is called as a dot and cross diagram. Then we are going to put an arrow, and before the arrow we are going to show through the arrowhead. The tail is towards the atom which is losing electron and head is towards the atom which is gaining electron. So this arrow actually shows the transfer of electron, and this arrow represents that we are going to see the product now. After losing electron, this sodium ion is formed, which is having positive 1 ion, and this chloride ion has gained the electron, so this is -1. And the electronic configuration will be changed to 2,8 for sodium ion, and chloride ion is 2,8,8 as it has gained 1 electron. As you can see from the diagram, this dot is, as it has gained the electron from sodium, and we are showing the electrons of sodium in the form of dot. So this chloride ion, which has this dot, shows that that is being taken from the sodium ion. So this is how you show the formation of ionic compounds by dot and cross diagram. You can pick up your notebook and write down draw the formation of calcium chloride by dot and cross diagram, potassium oxide, sodium oxide. Any example you can try out of these which I have just told you. So this is very, very simple. It's not complicated. Only the steps you have to follow is first write the electronic configuration of neutral atom for both metal and non-metal. Then with the arrowhead transfer electron. Then with this arrow show the products which are formed for the cation, positive ion at the top, and for the ion negative at the top. This is how it works. And in case you have any question, you can just write down in the comment section. Okay, another example we are going to discuss is the formation of the magnesium chloride. Why I have chosen this example? Because here we are having one atom of cation and two atoms of anion. So if cation is 1 and anions are 2, so we are going to draw it twice. Because we know that chlorine needs 1 electron. So 2 chloride ions will be formed when magnesium will lose its 2 electrons to 2 chlorine atoms. So magnesium will be written in the middle as it is having +2 charge, as it is losing 2 electrons. So both the anions will be written on both the sides. And you can see that these two crosses are representing the 2 electron, which you can see here, each 1 electron in each of the chloride ions. So as cation is 1, anions are 2, so cation is written in the middle with +2 charge, and anions are written on both sides with the negative charge. So this is how we show the formation of the magnesium chloride by dot and cross diagram, and we follow the same rule for the similar type of ionic compounds where we are having 1 cation, 2 anions, or 1 anion and 2 cation, like potassium oxide, K2O. So you can take out your notebook and you can practice for K2O formation by dot and cross. So this is all about, and if you have any question, please feel free to write in the comment section. I'll read and I'll answer. Thank you so much. Take care.